families. Family size is given. Main occupation is given, that is coded actually. A for agriculture, B for business, S for service. And family type 1 or 2, it is given there. And that 1 or 2, I think one is for joint family, another one is for nuclear family. And income is given. Then health problems, respiratory problem, is it there, yes or no? If yes, it is coded as 1, no, it is 0. Vector-borne diseases, are they there, yes or no? 1 and 0 are given. Then jaundice, has it occurred, yes or no? 1 and 0 is given. So data is recorded in this way. Now we have to open and perform this analysis. So these are the questions given. Obtain the descriptive statistics of income. We'll first do one thing. We'll have to open that SPSS. It takes some time usually, I don't know. It's slow. Yeah, it's opening. So I have opened the file. We have to open a file. This is a procedure. File, open. Now I am opening a data file. So data. When we go to the desktop, actually it's stored on the desktop. So today's exercise SPSS and SPSS 3A. So this is the file, the data is entered, and we have to check up whether the variable views, variable information are correct. Here, only main occupation is given as string. Variable view can, yeah, it is given as string, there's no problem. And also, main occupation we have coded agriculture, business and service, and family type 1 for nuclear family, 2 for joint family. That's also done. And again, the diseases say 0 for no and 1 for yes. Similarly for the other 2 I have coded. So this arrangement, let us check the levels of measurement also. Case number, of course, nominal. Family size, of course, it is scale. Main occupation is nominal, family type also nominal, and income, it is scale. And then respiratory these diseases, those are nominal things. Now come back to this. First question was, get the descriptive statistics of income. So as I have been telling already, come to analyze descriptive statistics and frequencies. Here on the left side, all the variable list is there. The particular variable you want to analyze, you take it and keep it on the right side. And go to statistics. Then what are the descriptive statistics in mean, median, mode, and quartiles, if you want, you can take that. And standard deviation, you can take that. Minimum, maximum, okay, range also you can take. Skewness kurtosis, of course, we have not studied in the first year, so we'll leave them. Say okay. It has come with a frequency table, we can remove that. So here in this table, the small font, all the descriptive statistics are given, percentiles also are given. So the answer have come. Now what is the next question? Second question is, obtain frequency tables and bar diagrams of family size, main occupation, and family type. So you can do this one. Come here. First of all, send this back. Then family size, main occupation, and family type. And frequency table, it is on, and also you need bar diagram. Okay, and statistics, you please put off all these things. None of these are required. We chose it last time, therefore they remain like that. Okay, now click OK. Bar diagrams, it takes some time. So these are the three frequency tables. Say family size, the values, the frequencies, then percentages and other things are given. Main occupation, agriculture, business, service, their frequencies are given. And family type, nuclear and joint, their frequencies are given. This is the family size bar diagram. 2 to 10, the diagram is given. Main occupation, agriculture, business, and service. The family type, nuclear and joint also is given. Okay, now we'll go to the next one. Next question. Verify the normality of income. Say last year while teaching the testing of hypothesis, we discussed what is normal distribution. It's a bell-shaped curve. So income, if it is plotted, are we going to get a bell-shaped curve? So there are a number of tests for that. Okay, we will be performing that, and we will go to the data for that. So the test, you have to proceed like this: analyze, descriptive statistics, and explore. You can write down somewhere all these navigations. Analyze, descriptive statistics, explore. Okay. Then income is a variable of interest. So you put that one. Okay, then what all you want? So here descriptives, okay, and then plots, stem and leaf plot, histogram, and normality plots with tests. So this much you have to include: stem and leaf plot, histogram, and normality plots with tests. And after that, click OK. So explore the answers are starting from here. So first thing is case processing summary, means what percentage of the cases are processed, because missing values will not be processed, but here there are no missing values, so 100% is there. Now, in the descriptive, what all are there? So mean value is given, 95% confidence interval. This is a concept which you have not studied, so leave it. Then 5% trimmed mean. Trimmed mean means outliers, means extreme values will be removed and mean will be calculated again. That's a trimmed mean. Then median is given, variance is given, standard deviation is given, minimum, maximum, range, all such descriptives are available there. Then test of normality. So last year when learning the testing of hypothesis, we said there will be a null hypothesis, there will be an alternative hypothesis. We have not learned about how to test normality, but procedure here it will be like this. Null hypothesis will say that the given data follows normal distribution. Alternative hypothesis will say it is not, it does not follow. Okay? So these are the two things. So after that, this test, its name is Kolmogorov-Smirnov test. And Shafarov-Wilk test also is there, but we will look into the first test only. So according to that, some statistic is calculated. And from that point to infinity, what is the area under the curve? That area is 0.2. If that area is 0.2, that is greater than 0.05. So usually in our testing procedure, what we conclude, if it is greater than 0.05, we accept the null hypothesis. And what's a null hypothesis? The given data follows normal distribution. So it gets accepted. To conclude it further, histogram is given. It is nearly a bell-shaped curve. There is some deviations here. And then a QQ plot means observed value in thousands, largest value maybe below 60,000. So it is written here. And under the assumption it is normal, what will be the standard normal value corresponding to that? That is also written here. And the graph is plotted. If this falls on a straight line, it means it is normal, or a near straight line also taken as normal distribution. And here the variations from this line, that is taken and plotted in the next one. So here the variations only from 0. Some of the variations are negative, those who are below the line. Some of the variations are positive, those are above the line. So those variations plotted, there is no pattern visible there. So that also can conclude that it's normal. And this box plot, actually in box plot what we have, the lower line here, which I am showing here, see this line. This line is minimum. And the upper line, this line is maximum. And the middle line is Q2 or median. And this line is Q3. And this line is Q1. So minimum, Q1, Q2, Q3, maximum. So if it is all symmetric box and adjacent things, then we can conclude it is normally distributed. This is the usual procedure, how we conclude whether something is normally distributed. And we'll go to the next question. Create multiple response group for illness and also create its bar diagram. So multiple response group, how do we create? Last time I think we have seen that. We have to go to transform, I think. Data. Define multiple response set. So is it about illness? So all illnesses here, respiratory problem, vector-borne disease, and jaundice. This you can move to the right side. Okay, and counted value. If it is yes, we count. Counted value should be 1 then. Set a name it is, you have to put it. I'm putting illness. And we have to add it here. So it is there and click OK. So it has informed us that there is a multiple response set created. That is called illness. Counted value is 1, and these are the 3 variables involved in it. Now using this one, why we go for the multiple response set? Say, look at the data. Say in the same house, sometimes 2 diseases can come. Okay, so that is why we gave the data like this. And now we want to create the graph for this one. What you have to do, we cannot go for bar diagram here. If you do the usual procedure here, this side, that illness will not be visible there. So what you have to do, you have to go to graphs, chart builder. Click OK. And here, put this bar diagram there, and illness is shown here. Drag it here and click OK. So that bar diagram has come. So jaundice, nearly 5 people. Respiratory problem, nearly 8 people. Vector-borne diseases, 9 people. It is shown in the graph. These are 3 different variables in the data, but we can create a single graph out of it. And the next question. Obtain the correlation coefficient between family size and income. Again, it's a very simple thing. Just come to analyze, correlate by variant. Just you have to move the family size and income there. Click OK. So here you get the answer. Answer is 0.035. 0.03 is very negligible. Practically, we can say that there is no correlation between family size and income. Now, the next question. Obtain the mean income of agriculture families. Mean income of agriculture families. So I have to separate the agriculture families. So how do we do? You can go to data, select cases, and if condition satisfied, if say the family type is equal to, within quotes, capital A, you have to give. Continue. I think quotes are not required. Just 1 minute. A. Continue. Family type. Oh, sorry. It is main occupation rather, not a family type. Sorry. Yeah, here. Come. You have to give. We need to give the codes there. So click OK. So all other families, say business family, that is removed. Agriculture family, that is retained. So what's the question? Obtain the mean income of agriculture family. So we have to come here, analyze descriptive statistics, All these things you can remove. Income, it's mean. Thing charts, nothing. Okay, we have to remove. So there are 16 such families are there. Their mean income is 27,125. Next question. Obtain the mean and standard deviation of income of each family type. Okay. Now each family type we have to deal. So first of all, you have to come back here. This select case, you close it. All cases are selected. Now family type wise, we have to divide. So you have to come here, split file, compare groups, family type, click OK. So after that, what actually is the question? Mean income of mean and standard deviation income of each family type. So we can come here, analyze descriptive statistics, income, mean and standard deviation. This is standard deviation. Say OK. So here nuclear family, for income, their mean is 26,000. Standard deviation is 13,000. And similarly, joint family, their mean is 23,000. Standard deviation is 12,000. So the output have come. Now after that here, whenever we use split file or select case, after that come back and say analyze all cases. Do not create groups. Okay, then the next one. Recode income into 3 categories: low income group, middle income group, high income group. So how would we do that? So low income means below 8,000, high income means above 20,000. So we'll do that one. So come to transform, record into different variable. And income is to be done like that. And new variable, we can make it income group. Okay, and change. So it has come here, old and new values. Always use the range. So below 8,000 means I can go up to 7,999. Okay, and the output variable will be string. So here I can say it is low. And 8,000 to 20,000. And here you give the value as middle income. And the third one, 20,000, 1 onwards, anything up to say 2 lakh or more than that. Okay, and it is high income. Okay, and I got this one, continue. Say okay. Now look at the data sheet. So here it has come. Even it can be centered if you want. You can go there and make it centered. So now it is visible. Everything is classified. And the next one, create a cross tabulation of income group, occupation, and family type. Income group, occupation, and family type. Okay, you can do this one this way. Come here, analyze descriptive statistics, cross tab, income group, occupation, and family type as a first layer. We can put it here. So it's a 3 variable classification, not a 2 by 2 variable. So it has created that bigger table. Say here nuclear joined these 2 rows, and each row is divided into 3 different sub rows, income group wise, high income, low income, middle income. Similarly, joint family also divided into 3 sub rows. And here column 1 for agriculture, column 2 for business, column 3 for service. The row totals, column totals, and the grand total is given. So 3-way classification is possible here. And create a bivariate table of income group and illness. That also you can do here. Here for bivariate illness, actually we have used multiple group actually. So you cannot do directly from this table arrangement. Okay, you cannot go to analyze descriptive statistics and cross tab. This will not work, because even if I go there, say here, that illness will not be visible. So what I have to do, this is between table income group and okay. This what you have to do, you have to come here and come to this analyze table, custom table, click OK. So illness you have to put it here, and income group we have to put it here. Click OK. So they have created that one. Say illness, respiratory problem, vector-borne diseases, jaundice, and high income group, low income group, middle income group. Totals are not given here. Of course, the specifications are there in the dialog box. If you want, you can go there and get those specifications. So this is over with this.